Okay, so I want to go over this area function, right? So if we're given a graph like this, right, we call this f of t, and we want to find out, want to answer three questions, right? One, we'd like to find out what is the function, right? Determine a function for f of t. B, find a1, right, which will calculate the area at x is equal to 1. C, find a5. Right, and that'll calculate the area at 5. And then finally D, find a formula for just any value of x. That calculates the area, right? So if I give it 2, I can plug it into this formula, and then it'll give me the area for under the curve between the t-axis and the curve f of t. Okay, so from the graph, one thing I noticed right away is that the slope is 1, right? Just kind of looking at the rise over the run. And that means that I can approach finding the function as two separate ways. I can think of, well, it's two lines. I can create a piecewise function. Or one thing that sticks out to me is that the slope is 1, so that I can think of the parent function as being the absolute value of x, right? That looks like the absolute value. Again, there's some restrictions, but I'll bring in the restrictions in a second. The restriction here is that x just has to be bigger than 0. Right, so it's the absolute value of x, which has a slope of 1, but it's shifted over to the right 3 and up 2 units. Right, now in terms of my translations, or I guess I should call it the absolute value of t. In terms of my translation, that means that f of t is going to be equal to the absolute value of x minus 3. Right, that corresponds to a shift over on the right, and a shift upwards is plus 2. Right, and these are for x greater than or 0, greater than or equal to 0. Okay, now if I want to write this dropping the absolute values, then this turns into a piecewise function when it's here on the left side of 3, right? We have a negative slope, so we make this negative, and we get reducing here, kind of combining like terms. And this is valid between 0 and 3. Bigger than 3, it's a positive slope, so we can just drop the absolute values, and negative 3 plus 2 is 1. So we get x minus 1. And this works for values of greater than 3. Or equal to 3 at here. Doesn't really matter where you put the equal sign for the endpoint, right, since they connect. Okay, so that now we have our function f of t. So now let's take a look at the area. Right? The area when x is equal to 1. Right, so what we hope to find here is the area under this curve. Right, now looking at this shape here, right, now here all I need to solve all of these questions is really just the knowledge of piecewise functions and some basic geometric formulas here. Right, the shape that I see here is a trapezoid. Right, so here, all right, so to find a of 1 is equivalent to using the area of a trapezoid. All right, so here the area of the trapezoid for, if I call this base 1, base 2, and then this is the height, right? Then the area of a trapezoid is the average of the bases, right? Or add them up, divide by 2 times the height. Okay, so now looking how that applies here, the height is kind of on its side compared to what it's shaped here. So the height is 1. All right, base 1 would be here, 5. And then the value, so this value here is actually 1, f of 1, right? So we plug in 1 here, negative 1 plus 4, excuse me, negative 1 plus 5, we get 4 over 2. So we get 9 over 2, or 4.5 square units, right? Whatever those units happen to be. Okay, and that's how we find the A1. All right, so now what happens as I go up further to A5? Now this does not look, right, so here I want to find all of this area. Okay, now this doesn't look like a basic geometric shape that I'm used to, but I can actually make it look like that by splitting it up into 2 shapes. All right, or in this case, 2 trapezoids. All right, from 0 to 3, I get 1 trapezoid, and then from 3 to 5, I get another trapezoid. Right? So again, just using basic formulas of geometric shapes, I can calculate the area here. Right? So for C, right, A5 is going to be, we'll call it trapezoid 1. And trapezoid 2. Okay, so looking at this here, right, the height for the first one is going to be 3. And the base, one of the bases is 5 here. And the other one is, here I'll have to evaluate the height here along this way. That would, this point again is 3 f of 3. Let's use the kind of getting scrunched up there, but plugging in 3, oh, I noticed these should be t's. Sorry, I should really keep my I always want to make everything an x. My apologies here. I should really keep my variables straight. Right, so this should be a t. Okay. All right. So here, f of 3, the other one, we, again, doesn't matter which one, we'll get the same solution here. Plug in 3 minus 1 is 2, so that is our second base along here. All right, so 5 plus 2 divided by 2. And I'm going to add to that, right, the height for our second trapezoid is 2 units. Base 1 is shares one of the bases, and again here is the value of f of 3, which I found to be 2. The second base would be this distance here, and that has a value of f of 5. Plugging it in here, 5 minus 1 is 4, so the second base is 4. Divide by 2. Okay, so here we have 5 plus 2 is 7, times 3 we get 21 over 2. Here we get those 2's reduce, we get 6. Right. And this is, right, 10.5 plus 6 equals 16.5 square units. Okay. All right, so that covers A, B, and C. right? Now how do I find just a general formula so that I can just take a value of an x, plug it in, and get these values here, right? Without having to worry about calculating some kind of geometric shape from a graph. Just a purely algebraic formula that I can use. All right, so let me redraw our graph here. Okay, 1, 2, 3, 4, 6. 1, 2, 3, 4, 5. All right. So it looks okay. Now, again, I'm going to use the basic geometric shapes to come up with a general formula, right? Now, from our working through of B and C, I do notice that at least that I'm going to have a piecewise functions, that anything between 0 and 3 is just a trapezoid, right? So again, when I say x, what I mean is what would the area for an arbitrary value of x be? All right, so if this is an arbitrary value of x, all right, we're going to essentially do the exact same thing I did to find a of 1, but instead of 1 here, I just use x. All right, so the height of the trapezoid is the value of x. So that is the height, and multiply by the bases, right? So here, the base would be one of the base, no matter what the value of x is always 5. And the other base would be this distance here. And again, that point there is x, f of x. Okay. All right. So x, f of x, right? So the height of it would be the value of x, but that comes from this here, right? So f of x would be negative x plus 5. And then all of that divided by 2. Okay. All right, so reducing this, we get x times negative x plus 10 over 2. Reducing a little further, distributing that x into here, negative x squared plus 10x over 2, or negative 1/2 x squared plus 5x. All right, but again, notice that this only works for values between 0 and 3. All right, so what happens when I get values that are larger than 3, right? Now again, we're going to do the same approach that I did with part C, where I thought of it as 2 trapezoids, because after we get greater than 3, right, for all values that are bigger than 3, the area is always going to include this part of the trapezoid, right? If you think of, well, let's look farther up, right? And again, right, here we've calculated between 0 and 3. That I'm not worried about, right? That's what a piecewise function does for me, right? It says, well, what about this is only going to apply for values that are larger than 3. Okay? So values that are out here, let's say. Okay, so any values that are to the right of 3 is always going to include this trapezoid. right? So that formula will always include this part, right? And that part is going to be, this has height of 3. One of the bases is always 5, and the other base would be the y value here, the distance here, which is f of 3, right? And from my formula, f of 3 is going to be 3 minus 1 is 2, so that second base is 2. Okay, so that is always going to be part of it, right? For any value out here, that's going to be height 3, base 1 plus base 2, and divided by 2. So that's always going to be part of my formula, right? What's going to change is this value for x here. Okay, so I'm going to add to that whatever this arbitrary value for x is going to be. Okay. All right. And then adding to that, now here, let's be careful here, right? What would be the height here? It's not x, right? It'll be the difference between x and 3, right? So the height would be x minus 3, right? One of the bases is 2, right? And the other base is the distance here, which is f of x. Now notice it's larger than 3, so coming over here, it'll be this part, x minus 1. Okay, so if we do a little simplifying here, we get 7/21 over 2. X minus 3 and x plus 1 over 2. All right. Okay, let me keep reducing here. So I'm going to FOIL this out, distribute x squared. The middle term will be minus 2x. The last term would be minus 3. All of this over 2 is 21. Okay, and again, just continue here. Minus 2x minus 3 plus 21 is 18. All over 2, and lastly, we'll just divide all the terms by 2, right? And again here, this only works for values that are, greater than or equal to 3, or simply greater than 3, since we got the equal part here. X greater than 3. All right, so let's put all this together in one piecewise function. And here we're going to have the area of x is going to be equal to negative 1/2 x squared plus 5x. And this will be for values that are bigger than x but less than or equal to 3. All right, and 1/2 x squared minus x plus 9, and these will be for values of x larger than 3. Okay, all right, and then we can always double check our work from part B and C, just to kind of confirm that this works. If I choose a of 1, I could plug it in here. So negative 1/2 times 1 squared plus 5 times 1. And we could see that's just 1, so negative 1/2 plus 5 is 4.5 square units. Okay, right? Just like we got in the previous one, right? An a of 5, we get 1/2 5 squared minus 5 plus 9. So here we get 25 over 2, negative 5 plus 9 is 4. Okay, and then that gives me 12.5, 25 over 2 plus 4, which is 16.5 square units, which is exactly what I got for part C. All right, but here we just have one nice function, right, that gives me the area formula for any value of x, right? I can throw at this function 6, 1.5, 2, right? And that would give me the area formula just by plugging it into this any one of these quadratic equations, right? Just depending on what the value of x is. Okay, thank you.